In this video, we're going to take a look back at an example from section 5.3. So in that example from section 5.3, we had a group of 3 Republicans, 2 Democrats, and 1 independent. And from those 6 people, there is a committee of 2 people that is being formed. And it's being randomly selected. Y1 is the number of Republicans. Y2 is the number of Democrats on the committee. And we want to know, is the number of Republicans in the sample independent of the number of Democrats? Right? And so, to do that, we can look at the body of this table. That body of that table right here, it is representing the joint probability function. The row sums, these totals right here, so going across the top, those are Y1 values, and so this row sum is actually adding up over all the Y1 values. So this is the marginal density, the marginal probability for Y2. Across the bottom, those column sums, those would be the marginal probabilities for Y1. And so we want to know, is this sample, is this independent? The number of Republicans, is that independent of the number of Democrats? And so if it's independent, then every single one of the values in the middle, in the body of the table, should come from taking a product of the marginal probabilities. And so we could observe, I don't know, the probability of having 2 Republicans on the committee and also 2 Democrats. That's this value right here. That is 0. However, when we look at the marginal probability of having 2 Republicans times the marginal probability of having 2 Democrats, the marginal probability of having 2 Republicans is right there. That's 3/15. The marginal probability of 2 Democrats is 1/15. And that product is pretty clearly not 0. So these 2 values right here, they are not equal, so they are not dependent, or they are not independent, they have to be dependent. So those are dependent. All right, in the next video we'll take a look at an example for a continuous case.